Okay, while the presentation is being loaded, quick background. So, Coursekey is an education platform and part of a whole suite of product that we offer to the schools to help manage their campus, from student attendance, assessments, all the way to compliance or regulation and help with the accreditation process. And part of doing all of that, we have to take attendance for students. And to be able to take attendance, we need to know exactly what time class starts and what time class ends. And that's pretty easy when you're dealing with one campus, one school here at San Diego State, right? It's super simple. You just know what time it is and you use it. Then we started expanding multiple schools across the whole United States, and things got a little bit more complicated. And in this world nowadays, after COVID, we all shifted to remote work. And with part of remote work, what happens is we deal with people in different locations, and be it even onshore, offshore, nearshore, wherever you want to call it, people are on different time zones. And to be able to deal with all the time complexity, we're using software. And to understand how the software works, we need to know how time underneath the hood is set up in the computers and the servers that we're using day to day to be able to address this problem. So my presentation touches on this and will cover how the computer and your devices by extension know what time it is. So, okay, there we go. So the simplest thing we all know about is time zones. And it's pretty straightforward. Typically, back in the day, people use GMT, which is Greenwich Mean Time, to use as the reference, and you just add or subtract time based on your location. And people did the simple math, and you figure out what time is equivalent in your local time. However, nowadays, things got a little bit more complicated, and you can see how many different time zones there are as we expand, and there's a whole map of the world. Not going to dive into that. But what happens is we all know we get that one time or two times a year where things get a little bit complicated with daylight savings. And every year we have the same debate if we should keep it or remove it. Well, computers have to deal with that. And depending on what you're doing, you typically either add or remove 1 hour. And that gets a little bit more complicated when you're dealing with times in international areas, right? So like US does their US does their daylight savings, then Europe does their daylight savings, and there's a window where we're 1 hour off, then it's 2 hours off. And to add to the complication, you have your southern hemisphere, which does the exact opposite of what we do. So if we add 1 hour, they actually subtract 1 hour because they're having their summer versus our winter. So basically, when we learned all of that, this was my reaction. I have to deal with all of this, all these complexities, build all these algorithms to be able to decode what time it needs to be so I know when a student is supposed to check into their class. So it doesn't even get that simpler. It gets more complicated. For example, in the US, right, we got Arizona, which basically is a nightmare because even though it's in the US, they decided that they're not going to follow daylight savings. However, there is the Native American regions where they basically said, no, we're going to keep using it because we're working with the other states around us, and we expand on it. Then there's a region within it that they said, no, we're going to follow the state we're in. And you can see basically on the map how complicated it is. So even though we know Arizona doesn't follow daylight savings, it's not really true because depending on your exact geolocation, they might actually follow it. So it's very complex. Now, you would think that would be it, right? Like, okay, daylight savings, we can figure out the rules, find the outliers, document those, follow, build something, gather requirements, it's all set. Then we're into Samoa. Anybody know what the special about Samoa? Well, it is on the international date line. So you saw the map of the time zones. So Samoa literally falls on the opposite side, on the middle, where the both sides of the time zones meet. Because you start from Greenwich, which is the zero base, and on the right is positive, and on the left is negative. Samoa is where those two meet. So basically what they did was, in 2011, they decided that they wanted to skip a day, and basically went from December 29th to December 31st. Well, let's hope nobody had a dentist appointment on December 30th. That's all I'm going to say. And the reason for that was because they switched from the from the negative to the positive side of things. And the reason for that was because it helped them trade with Australia. Because they were a day behind and Australia was ahead. There was time difference and it was causing issues, and they trade a lot with them, so they decided to switch the time zone. So this was my face after that, because now it's not just that you have time zones and you have the daylight savings rules. The time zones themselves are changing. So does that mean there can be more time zone changes? Well, let's take a look. So one fun fact I learned was during World War II, England decided to do double British summertime. So it's basically the daylight savings, but they did it twice. What that meant was it added an extra hour, 2 hours, as I just mentioned it. Basically what that meant was Greenwich, the city in London where it's supposed to be the base of time as the zero time, was actually 2 hours ahead of its time. So like you're in the city that's supposed to be the base, the zero time, you're 2 hours ahead of it. Imagine the chaos, especially when trying to do trading and working with the other side of the world. So, is there a solution? Well, we know the time zone changes often, and people knew that. So, we developed the earliest thing back in the before the 70s, I would say. No, I don't know, sometime in the past, right? They developed an email list where they would basically take the email list and notify people of any time zone changes. Did that work? Well, yes and no, depending on when the change happened. So, for example, just recently, literally this March, in Lebanon, there was a time change with only a couple of hours notice that they decided that they were not going to switch to daylight savings because of Ramadan. Because it was supposed to start, and it's based on the lunar calendar, and didn't start, and daylight savings happened and decided to switch. It's complicated, but you can see things happen, and there's very short notice when things like that happen. Same thing happened with Libya. But Libya gave us at least a couple of days notice, and they decided that they weren't going to observe daylight savings when they were supposed to. And that caused chaos as well. And all those changes, imagine if you have a flight that you're supposed to take and you live in that country and your time is shifted and your airline is working internationally trying to decode and figure out what time it is. So what is the current solution? Like, how does the software, your server, your computers, your technology know what time it is? Well, there's this thing called the TZ file, or time zone files. Those are part of the Linux operating system. They tell you the time zone based on the location. It's a massive table. It has mathematical formulas. It decodes, it links things, and it figures out the time for you. So all you need to do is keep it up to date, and it will figure out the time for you correctly. So at this point, I'm looking at it. I'm like, this is all, right? It can't get any more complicated, right? We figured it out. Time zones, daylight savings, changes. We got it all under control. Well, not if we run into some special cases, because the world is not that simple. So we have the West Bank, right? And basically you have two populations living in the same exact location, but they follow 2 different time zones. So far, we knew, like, if we knew the exact location, even if it's the same state, different areas, we can figure it out. Now, we can't anymore. Just because if you're following a certain population, you're going to follow their time zone. And at that point, technology can't help you. Like, at that point, it have to have a person select which time zone they want to use. And I think this is it, right? Nope. The further we look back, the crazier things get. So hopefully you're not building a historical app or something that does with history or backdating, because things get a lot more complicated. For example, we changed from the Julian calendar to the Gregorian calendar. And what that meant was we actually skipped 11 days. So there are 11 days missing from the calendar. And those days are specified somewhere. That happened for the whole world except for Russia. And basically now we have 2 dates for the same exact day, but depending on which location is documenting it, it references that day. And a fun fact, those 11 days are why the Eastern Orthodox churches celebrate Christmas on January 6th instead of December 25th. And it gets even more complicated as we dive into further back. So one time we went from March 24th, 924, to March 25th to 925th. And the reasoning for that was somebody forgot to update the calendar properly when they moved to the next year, and things were documented and recorded with the prior year. So you have 2 dates same date for 2 different days. So yeah, it gets complicated. Then there's this phantom time hypothesis. You can dive into that, super complicated. It's linked to the Dark Ages. Fun read if you're interested in finding out. And the further back we go, crazier things get with time. And on top of all of that, we have the leap second. What is a leap second? So basically the Earth doesn't rotate in a constant speed. Things change based on earthquake, natural disasters, all that stuff, magnetic, scientific fields, all that. So because of that, we actually have an extra second. So what happens is the clocks are supposed to go from 23:59:59 to 23:59:60 instead of 00:00. Well, that's a simple thing, right? Well, not really, because everything we program is set to be 60 seconds, not 61 seconds in a minute. And this is extremely important if you're working with telescopes, outer space, any kind of aerospace engineering outside of the atmosphere stuff. So this is getting out of hand. Like, how do we take it anymore, right? Well, luckily, the Unix timestamp came to the rescue. So in 1970, we created this beautiful system. That's the UTC that you see most of the time now when programming. It stands for Coordinated Universal Time, but it's UTC. I don't know why. I haven't dove that deep into it. But it basically counts everything and addresses most of these issues, because what it does is it counts every second and it keeps counting up. So it just does the seconds count, and it handles everything from leap years all the way to the leap second and so on. And most systems nowadays handle the leap second by just repeating the 0 second or the 59 second. And because it's such a small thing, we don't really notice, and it goes by unnoticed by people. So what is our logic? Like, how does our system work now, right? That is a good question. Originally, we wrote things We built algorithms. We took all that out and threw it in the trash because it was not worth the hassle. Then we used a library that was built by people whose full-time job was to maintain it, and it worked for a little bit. Then the systems, the tooling, the languages we were using evolved over time and added native support. So we started leveraging those operating system tools to address all the time calculations and the time differences and so on. A fun little bonus solution for leap seconds. Google built their own solution to it, and they called it the leap smear. So instead of repeating a second, especially if you're using Google services and let's say you're doing banking, right? You don't want people take advantage of that repeating second to do double spend or do multiple transactions. You need to make sure your records are chronological order. So they build the system where they take that 1 second and stretch it out throughout the whole day and literally add microseconds every second. So by the end of the day, it adds up to that 1 extra second. Yep, I just covered all that. And that way you can make sure you have the full trust that every record is on time. And that's basically it. Any questions?
Are you using any real-time source of time like NTP servers?
So NTP is not as accurate most of the time. And usually, especially if you're using cloud services like AWS and stuff, they are under the hood, leveraging NTP and all of that. So as long as you have your server time as accurate as possible, you're pretty much set. On the client side, on the user end, things get a little bit more complicated. I mean, part of this presentation, just because I don't have enough time, what I do usually is ask people what time it is. And depending on my luck, if some people will give me different times at the same exact minute, because somebody has an analog clock that they moved it forward. Other people might have a digital one that's synced, but is like 1 hour behind. 1 minute behind or a minute ahead, depending on their NTP service that they use to sync the time. So it's accurate, but not 100%. And for users end, you just have to rely on the server most of the time.
What do you think of the idea of just doing away with time zones altogether and just having a single universal time for everywhere on the planet? Do you think that idea has merit? Is it any chance of success? I'd love to know your thoughts.
It will be very difficult because people are creatures of habit. And when you're used to morning being certain time, and like people get very upset with daylight savings, and it's just like 1 hour change. Now imagine, at least for us, it will be -7 hours or -8 hours. So like right now it's, let's see, it's probably like 23, so it's 11 p.m. UTC. So yeah, I would love that. Yeah, for me, I would love that. From a programming standpoint, from scheduling, I would love it. And the other thing is that I took out from the presentation is we have like our current time zones and things on Earth, but now imagine with like colonizing Mars and the moon and figuring out time and coordinating between Earth and moon time. It's going to get a lot more complicated. And it is already complicated. Like there is people who are having hard time figuring out like which formulas to use. Do we follow like atomic clocks, the Earth time? How do you figure out which, because there's dilution, there's whole relativity stuff, it gets into it. There's a lot of complexities. So
many companies get this wrong, as you know. I wonder if you comment on the various airlines when you book a ticket and then you say add to calendar and you drag the flight to your calendar. So for international flights,
they sometimes get the start time correct, but the end time is way off. Sometimes the end time is actually in the local time zone, or they get a confusion when they're trying to place it on the calendar where they start time and a duration, and the duration computation goes wrong, or sometimes they do from start to an end and they've got the end time. Can you comment? How do you fix that?
Yeah, I mean, that's a very challenging issue, and it's really down to the UX and the product requirements and how the requirements were defined for the engineers. Because we actually ran into that issue ourselves, and we're still running into it right now. Basically, what happens is it's hard to define the start and end when you have two different locations, right? Because you display it based on, let's say, in our case, right, we have like online campuses, physical campuses, and you have students and you have administration in a completely different location. So different times for every single one. In our system, our approach was we're going to display everything based on the location of the user accessing that information. So you would see it in your local time. The thing is, when an administrator looks at a class and it says students checked in at 11 p.m., doesn't make sense. Well, the students checked in, let's say, at 7 p.m., right? So it is a challenging issue, just a requirement definition thing where how does it implement it? Now, the problem with the calendar, you download it and you import it to your system, that is an engineering, probably a bug, I would say, because they're exporting the data, but they're not defining the time zone. And when you're importing it, your calendar is assuming certain time zones, and that's why you're getting the discrepancies and issues, not following the standard properly for ICS.
Thanks.